Well, thank you very much. I'm told that I should kick things off here. My name is Caleb Scharf, in case you didn't know which of us was which. And it's sort of interesting as I was walking over here, feeling the skin on my face crisping up and about to slough off in a frostbitten state. And I was thinking, okay, actually, it's about the same temperature on equatorial Mars as it is, except it's a lot easier to breathe here. We have a lot more atmosphere here. Anyway, so it's a pleasure to be here with Lee, and just to get things going. A couple of years ago, I think we met and had a beer, and he told me he was writing this book. And my first thought was, oh God, because Lee is such a fantastic writer and such a thorough and thoughtful science journalist that I knew it would be a brilliant book. And it is a brilliant book. It's really a fabulous piece of writing. And as a scientist, I feel that it's an important book because I think it really marks a point in scientific history. And it does it with great skill. And it also captures the essence of the people involved in the science. And the other thing, which I guess I'll use as a jumping off point to ask you a question, Lee, is as the title kind of implies, 5 billion years of solitude. It has a slight edge of sadness to it, but reading the book, there's also a tremendous optimism. And I wondered if you wanted to perhaps say something about that factor in the book.
Oh yeah, of course. Well, first, I was actually going to say the exact same joke about equatorial Mars. Thank you all for coming out. It is really cold, and I also want to just mention, that Caleb Scharf here. Caleb is an extremely impressive writer and scientist, of course, in his own right. I only have one of those down. I'm a writer. I don't have the science part so much, but he's pretty uniquely poised, I think, to talk about a lot of these issues that we'll be discussing tonight, because he really has his feet in two different worlds. He started out as more on the cosmology side, extragalactic astronomy, things like that. His first book, obviously, is all about black holes and how they sculpt the cosmos, and in some cases kind of make it friendlier for life. But of course, he's also very involved in the exoplanet side of things and the astrobiology side of things. He even wrote a textbook about that back in 2008. So
it's not the most exciting read.
Point is, he's really one of the real deal experts and knows even more about the subject than I do. So back to the question though about the solitude and the sadness, the bleakness and the blackness that's in the book.
But also the positive aspects.
Yeah, it's a little bittersweet, and that was because I think partially of just where I was when I first found out about the possibility that we could go out and within our lifetimes maybe find other Earth-like planets around other stars. Coming up when I was in high school and in just a young pup in college, I was reading news reports all the time that were talking about how NASA and the European Space Agency were going to be building these big multi-billion-dollar space telescopes under various names. They were sometimes called terrestrial planet finders. And these things could actually, one was supposed to launch maybe, actually this year, I think, 2014. Another one was going to launch before 2020. And so, I was in a very optimistic stage, upward boost trajectory in my own life, just getting into college and looking at my whole life ahead of me. And I was thinking, gosh, I can't wait to be a real boy, a real grown-up man, and be seeing all these cool results coming down from the space telescopes. And that was one of the things that led me into the science journalism field and into this topic. And of course, I finally get up to the point where I can write a book about it, and none of it seems like it's going to happen anytime soon. So, I think that's really where the sadness and the happiness come in that we're really at this unique moment in time, and the first point in the entire history of the planet, where we could really seriously think about doing this, about going out and finding other Earths, finding life out there, knowing whether or not we're alone, or whether or not we might be special in some sense, or just common as dirt. And yet, it seems like we're really not prioritizing that. We're not very concerned about it, most of us, and it doesn't seem like it's going to happen for us, potentially for a very long time. So that's kind of in a nutshell.
Yeah, and just to maybe we'll just sort of start bouncing stuff back and forth rather than asking each other pointed questions that we were desperately trying to think up 2 minutes ago in the back room. Yeah, so it's very interesting because two comments as a scientist working in this field. In some ways, I'm probably more optimistic than you. I think there've been a lot of the stuff that Lee's referring to is to do with space-based telescopes, so very expensive, ultra high-tech devices that primarily NASA and the European Space Agency build and launch. And over the last, decade and a half, there has been an intent on the part of many scientists to build a generation of instruments capable of going out there, finding analogs to the Earth, and actually being sensitive enough to examine those objects in ways that could tell us whether or not there's life on those planets. And that's quite a reach, okay? But at the same time, I think although some of those projects, they were held up for a while as being the shining, sort of the holy grail in everyone's lives, and there wasn't enough money. And there also wasn't quite enough will on the part of certainly many scientists and politicians. But I think the field as a whole is not actually staggering too much. It's still going full steam ahead. Maybe we'll talk a little bit about that a little bit later. The other thing, as you were talking and you were relating it to your experience as a teenager, as a college student, and so on, what it made me think of, and I think for many of us in the field, and I think you feel this too, it seems the question of are we alone in the universe, the question of whether or not there are other planets out there, seems so big, so enormous, that it's almost like the Apollo era. Except they did Apollo. They went to the moon. Right? They set up this big thing saying, we can go to the moon. Well, obviously, there were political reasons behind that and so on. But it actually happened. And this feels like it should be on the same scale. But right now, we're sort of tripping over our own feet because of a lack of money and will on the part of... does that ring true?
Yeah, I think that all rings true. I mean, in response to your first comment about how you're more optimistic than me, I'm actually quite optimistic, and a lot has kind of occurred since even since the book came out. There's developments here and there in terms of people thinking we can do more things from the ground, or even build smaller space telescopes that don't necessarily cost quite as much money. So maybe this holy grail goal of finding other Earths isn't, a generation or two away beyond all our lives or anything like that. Maybe it can happen sooner, faster, cheaper. But of course, at some point you had a deadline, and you can't capture necessarily everything. But there's little hints of that in the book too, and we can get way deeper, of course, into what some of those faster, better, cheaper paths might be. And then, I do agree. It is similar to Apollo, except unlike Apollo, which cost well over $100 billion.
In today's money.
This is something that can be done for at least an order of magnitude less money. And you get really, and you can get into a really dangerous spot when you start doing opportunity costs, I think, for a lot of space science, because someone can always come back and be like, sorry, man, but that doesn't help anybody in Africa. What's the point? And that's true. But when you look at all the things that we kind of waste our money on, flagrantly and profitably in the world, and you compare it to how much it would cost to do this, that is kind of, I think, where the Apollo analogy falls apart a little bit, because it's not as expensive, nearly as expensive, and it does have, I think, a benefit that everyone can kind of see.
Right. Yeah. No, I can see that, and I think, this is a funny thing that scientists are always coming up against is. We say, well, it doesn't cost that much. It's only $10 billion to find another Earth. And I think the interesting thing is how the population gets divided. For some people, they get it. They say, of course, that's a tiny cost for this extraordinary piece of knowledge that could profoundly change us in all sorts of ways, especially if we actually found evidence of life somewhere else, even if it's microbial sludge on some distant planet. That would be a profound thing. But then, there seems to be a knee-jerk response, and it's true with some scientists as well, that, well, no, we've got so many problems here on Earth. But of course, I mean, certainly in the US, I think the total budget for NASA these days is less than 0.4% GDP, is that correct?
Something like that. It's pretty low compared to pretty much every other government agency.
And it's a lot less than is spent on, for example, mapping the human brain, which some people would argue is wonderful, but other people would argue is a fool's errand. So I guess, well, the interesting thing about your book as well is you really follow the personalities. Do you feel that, I think in the book there's a hint that some personalities are sort of shooting themselves in the foot as science personalities. Do you feel that is the case sometimes?
Yes. I don't want to go into, I'm not going to go into specifics about who I would think that about in the book. But yeah, there's definitely that element of it. There's, I don't want to say good guys and bad guys, but there's definitely lots of different sides to this. I mean, one thing that an astronomer told me when we were talking about our mutual frustration over, why can't we just launch this Battlestar Galactica style big space telescope for only $5 or $10 billion? As he said, well, you have to remember that every single time one of these projects gets over $1 billion, it's no longer it's not about the science anymore. It's about the politics. It's about the jobs, and it all of a sudden there's all these new questions that come into consideration, and it's just, it's very a lot of scientists, I feel like, aren't used to dealing with those domains necessarily, and that can make people make mistakes. But I think I might actually have to dispute a little bit something you said earlier, which is just the notion that finding microbial sludge someplace would really change people's lives. I mean, I think it would be, I don't want to put words in your mouth. You didn't quite say that. You said that it would be a profound discovery, and it would be a profound discovery for people who thought about it. But I feel like most people wouldn't think about it because it's so far away, hundreds of light years away, probably tens of light years away, so far beyond any place we could ever go or see anytime soon. So I don't know if that would do it. Maybe if we found some kind of literal mirror Earth where a green-skinned Caleb Scharf and a blue-skinned Lee Billings are talking about what's going on, that little bright star in the sky called Sol. Maybe then that would change people's minds. But to me, the thing that's almost more compelling is the notion that we may actually look out there and we may not find anything that looks very friendly or habitable or inhabited within whatever region of space we're examining. And of course, I don't really quite know what the probabilities are for that right now, and no one really knows totally, and that's why it's so exciting.
No one knows.
Yeah. And so to me, I think that's actually something that would resonate with everyone, because all of a sudden, if you're looking so hard, so arduously, so ardently for other Earths, other worlds, other life out there, and you just come up with nada, I think that would of course, people would just be like, we got to look harder. But then other people would be like, well, hey, maybe there is something special going on this planet. Maybe each of our lives and this moment we find ourselves in actually is somewhat special. And this is something that's profoundly against trends that have been going on for centuries in physical science, which says we're ordinary, we're average, we're mediocre, we don't matter. And that could really not be true on certain scales. Now, if we're looking at, the scale of big galaxies out there and the edge of the universe, well, chances are we really aren't special and we are insignificant. But within the Milky Way, maybe throw in the Magellanic Clouds, I don't know. I think there's a chance that we actually could be a little more important than we give ourselves credit for sometimes.
So he's beautifully led us into a discussion that that I want to have. Yes, so, and actually I can put in a plug here. My next book is all about this.
It's going to be a doozy, guys.
I think you're right. I think one of the most interesting pieces out of this, even right now, is that the stuff we've learnt, and I'll explain some of it in a moment, in the last 10 to 15 years about other planets, other worlds, has really, far from reinforcing the Copernican ideal that we're not special, that we're just mediocre, that there's lots of stuff like us out there in terms of planets and stars and so on. The crazy thing is that all the exoplanetary discoveries, all the studies of planets around other stars, are suggesting that the configuration of our solar system, the types of planets in our solar system, are rather unusual. We can actually now put numbers to that. And my guesstimate of it places us in a few percent club. So let me just give you a couple of examples. So the simplest one actually has nothing to do with planets. The simplest one is to do with the type of star that we live around. So we live around what's known as a G-dwarf star. And the interesting thing is that most stars are far less massive than our sun. Our sun is actually somewhat, although it's called G-dwarf, I mean, astronomers are terrible about this sort of thing. It's all this historical development of the field. We use labels that are not necessarily intuitive. 75% of all stars in our galaxy, and that's a galaxy of maybe 200, 300 billion stars, 75% of those stars are less than half the mass of our sun. Now, that means a number of things. It means they're much fainter. It means that the planets that form around them tend to orbit much closer in. But that also means that we're instantly in a small minority in terms of the type of star we orbit. And then when we look at the exoplanetary discoveries, what we begin to see is, and there are various aspects there, I'll just mention two of them. The first is that the majority of other planetary systems out there, and we now know of, well, we know of at least 3,000. Of those, I would say about 1,000 we have somewhat more detailed information on. What we find is that the majority of other solar systems have planets in orbital configurations very unlike the solar system. Our solar system has orbits that are fairly circular. Planets tend to be roughly orbiting in a circle as opposed to an ellipse. I mean, they're all orbiting in some sort of ellipse, but not a very distinct ellipse. And the majority of other planetary systems have much more elliptical orbits for their planets, for reasons that we think are deeply related to a history of chaos in planetary system. Our own solar system is actually chaotic, but that's maybe a topic for another. That's really, if you really want to sort of go home miserable, we'll talk about that. Mainly because in a few billion years' time, all hell is probably going to get let loose. Mercury will be destroyed. The Earth might get knocked into a different orbit, and so on, just because of chaos. Nothing else. No act of anything. It's just chaos. But so we think most other planetary systems have this slightly different configuration. We've also found one of the big results, I think, that has come out of NASA's Kepler mission, which is one of the space missions in the last few years that has really discovered so many planets that we can begin to make these statistical statements. It has found, and it's been confirmed with other techniques, that probably the most numerous, most abundant type of planet in our galaxy it's a type of planet that does not exist in our solar system. Well, do you want to say anything about that?
Just how wild that is, and I guess what I would go on from there. I mean, that's the other thing that's a little dangerous about this is, when you're saying that we know we can study these things quite closely. I mean, he's speaking as an astronomer. In terms of what?
Yes, I think 1 billion is a small number.
I mean, you can look at most of these planets that we're talking about, the ones that we know pretty well, and it's really you could scroll everything we actually know about them on the palm of your hand, basically. I mean, that's a slight exaggeration, but not really.
That's about it.
Yeah, you can know their orbit, maybe their radius, their size, perhaps their density if you're really lucky. You can figure out things based on the kind of star they orbit, maybe what the chances are for them to be, really metal rich, really rocky. You can look at the metal abundance of the star, things like that.
Okay, now you're talking like an astronomer. When astronomers say metals, what they actually mean is any element heavier than helium. So there's a very particular terminology there. Sorry, I couldn't resist saying that.
It's well, you always need to make it clear because always people think of big balls of steel or something, and we're talking, it could be gas. So, but the point is that these so-called super Earth planets that seem to be the most frequent kind that we see in all our surveys, we really don't have a good inkling of what most of them are like, or we're getting that inkling right now. And the point is this is a little pet peeve of mine, the phrase super Earth, which you see bandied about in the news. A lot of people, I don't know how many people here would actually know that term or pay attention to it. I pay attention to it all the time because I always have my Twitter feed open, and any single time a new discovery is made, a new super Earth is found, I see it. But we really don't know whether these things are super Earths, whether they're just big, swollen Earths that have big rocky, masses and just little thin atmospheres on them. A lot of them could be much more like mini Neptunes, for instance. But the problem, as you said, is that we don't have any in situ examples, so to speak. We don't have any that exist in our own solar system that we can really study very well.
Yeah. I mean, just to reinforce, so these are objects that are more massive than the Earth, but not as massive as Neptune, and that's quite a gap.
Right.
It's like, Neptune is what, 20, 30 times the mass of the Earth, something like that. And so it wasn't so much that people just hadn't thought about planets like that before, and the fact that they exist and they are probably the most numerous type of planet out there has really floored a lot of us. And they also, that there are hints now, in fact we were just talking about this in the back room, the very latest results, some of which were announced this week. In fact, there's a big meeting going on down in Washington DC at the moment. It's the American Astronomical Society annual meeting. It's like 1,500 astronomers show up in Wreck-A-Town. Well, actually,
astronomers know how to party, let me tell you.
Well, not as much as the geologists. And actually, I'm told at Columbia, actually just before the break, I was told that someone came up to me and said, if you really want to go to a good holiday party, it's the psychologists. But that's another story. So some of the results being announced this week include some very peculiar sounding results where, for example, a planet has been detected that is about the same mass as the Earth, as far as we can tell, but it's barely more dense than water. So what it means is that this world is either just some very strange blob of gas, which seems a little bit unlikely, or it's a rocky planet like the Earth, but it has some enormous atmosphere. And we don't really understand how that could happen. So almost on a weekly or monthly basis, there's new information coming in. These tiny little bits of information, like Lee said, you could write all of this on the palm of your hand for any individual planet.
And of course, even 2 years ago, that planet could have been found via some other technique, which we could get into if y'all want. We can talk about how we find planets and so on and so forth, and why we know so little about them, even though we know they're there for sure. But yeah, just a number of years ago, that planet would have been found, and people have said, oh, Earth mass. It's probably a big ball of rock. And again, we're just always surprised with whatever we see. So, kind of getting back to this whole notion of our expectations being upended. This notion that maybe we are special. What do you think, Caleb?
What do I think? Well, having spent the last year and a half writing a book and coming to a conclusion on that very question, so it's interesting. What is so interesting about that question, even from a scientific point of view, is how careful you have to be about the assumptions you unwittingly make when you try to answer the question, are we special, are we unusual, is there something going on about the Earth? And historically, obviously we had the whole Copernican side of things, mediocrity, etc. And speaking as someone coming out of cosmology originally, the principle of mediocrity is big in cosmology because it says we're not in any special place in the universe. The universe has no center. Of course, that also flows from Einstein's general relativity and our understanding of the dynamics of the universe. There is no center. But then people have gone the whole hog the other way to make arguments of so-called rare Earths, saying that the Earth may be almost unique. And the argument is that there appear to be such a chain of highly improbable events required for complex, intelligent life to have emerged on Earth that it seems very unlikely for this to have happened in very many other places. Now, I actually take that to task. I think that's... I'll keep my language clean. That's nonsense. Or it's nonsense. It may not be nonsense, but the evidence provided is not good evidence. And part of the reason is we have this very interesting way of dealing with inference, statistical inference. And for example, this notion that all these improbable things had to have happened for complex life to have emerged here on Earth. But if you go and look at it, you say, well, it all seems very improbable from our perspective after the event. But you could imagine going somewhere else, and an equally apparently improbable set of things could have happened and ended up with something else that's sitting there thinking, that's very improbable that I'm here. And the analogy that I use is, is, or one of the analogies, actually the simplest, most succinct analogy is that of the lottery. Okay, I'm walking down the street, I see a bus go by, it's got a number written on it. I think, why is that number lodged in my brain? And for some reason, later on in the day, I find myself buying a lottery ticket. Right, and maybe a few other things have happened during the day that have somehow sort of encouraged me to buy a lottery ticket. I don't actually buy lottery tickets. This is just a...
You can't win if you don't play.
Well, if I won one of these big lotteries, then we could have our planet-finding telescopes. That would be a perfect use for the money. But so I buy this lottery ticket, thinking, well, yeah, what the hell? I'll just do this, and I win. I think, if I hadn't seen that bus go by with the number on it, or if I hadn't tripped over that black cat, or if I hadn't, spilled my coffee, and I wouldn't. That is unbelievable, right? Except the problem is that someone was going to win the lottery that day, guaranteed. It was 100% probable. It just so happened to be me. So that question of, is the Earth unlikely? Is life on Earth unlikely? It's really a matter of perspective, right? On the global scale, it could be that there's lots of places that they're not going to be exactly like this. But the pathways to complex life, and conceivably the pathway, when I say complex life, I'm using it in the sort of biological, technical term, which means organisms with complex cell structures. Cells that allow them a much more efficient generation of energy, and therefore they can grow big and they can become like us. But so my personal take is that I think life here, the Earth, may be special, partially because we know it is from the astronomy. We know that the solar system is a somewhat unusual place, but then also from some of these other arguments to do with probability, biology, and so on. However, I don't think we're significant. Because I think through different pathways, different trajectories, you could arrive at similar situations elsewhere. They will be different, but they'll be out there, and there could be lots of them. That's my stab at it.
That's a nice distinction, though, between being special and being significant. I don't really know if we know whether or not we're significant. I think we have the opportunity potentially to be more significant than we are, and that's kind of getting back to the happy and sad notion of the book, the way that we're on the cusp of not only finding potentially other Earth-like planets, finding out whether or not we're alone, but also to be a little sci-fi for a bit. We at some point probably need to get off this rock, right? We have the capabilities where we could, some of us could go to space, some of us could potentially escape the solar system when the sun burns out and it becomes a terrible, terrible place to live here. Whether we'll actually do that, I don't know, and I don't know if that's what qualifies for significance. But you can imagine some kind of I guess, galactic empire building Death Stars and things. And
I know we're going to move to questions, but let me just respond to that, because it's funny. I was having this. It's interesting that you mentioned that, and this is something I must say in Lee's book is so beautifully and elegantly led up to this whole question of where are we going to go as a species? What are we going to do with this existence that we have? Because at some level, it totally is in our hands. But the interesting thing, just to go to your sci-fi example, the Galactic Empire, it occurred to me the other day that this sort of concept and civilization that's lived for millions of years always assumes that species doesn't evolve biologically. And the thing is, suppose it takes 1 million years to spread out in the galaxy. By the time you've finished it, you're a different species. And I always wonder if that just messes it up for everyone. Right, this is why we haven't seen any aliens, because they've just evolved into something else along
the great diaspora,
way and given up.
Oh man, I know we have to get to questions. I wanted to start talking about red dwarf stars and how long they can have biospheres, because so the most common star in the universe, real quick, and then we'll go to questions.
We could ask someone to ask that question.
Yeah, you can do that. We can.
Fabulous question.
Right there. Well, just the simple notion being that the most common stars, these really small ones that are very long lived. They can live for trillions of years. They can burn essentially. They've longer than the age of the current universe, and for again very, very long times. And conceivably, you could imagine some kind of biosphere growing up around them. I guess that could just kind of stay around and do just fine, keep developing for trillions of years. I mean, what would that look like? Where could you go with that? And the whole point is that we're very blinkered in what we can really conceive, based on where we are right now, and just the little kind of accidents or fate, whatever you want to call it, chance or necessity that led us to be here. So we have to go out and look. I guess
agree.
I'd like to end on that.
Yep.
Great. At this point in time, we can move on to the question portion of the evening. Does anybody have any questions for Lee? Start over here.
I'm actually really curious, Lee. I mean, I know you well, but I'm curious what you left out of the book that you really wanted in there. I've read it, but I'm really curious about that.
Well, so this kind of, I guess, gets back to some of the reasons for optimism. Some things that I really left out that I wanted to talk about were some upcoming extremely large ground-based telescopes. There are 3 big projects. One's called the GMT, the Giant Magellan Telescope. One's called the TMT, the 30-meter telescope, I believe. And one is called the ELT, the extremely large European telescope or something. It's
Well, I suppose it's actually, I think it's a European large telescope, not the extremely large.
Okay, right, that's what it is. So there's 3 of these things, and they're all kind of more or less going to debut circa 2020, give or take 5 years or so. And they have really, no one quite knows how far they can be pushed. And it's kind of the same thing with Webb. No one really quite knows how far Webb can be pushed. I guess I would really like to have had a lot more discussion of that stuff in the book, but it was kind of tough to squeeze in. And there's some of that in there a little bit, but not a lot. I kind of gloss over it. So, I left a lot of that out. Did I explain why? Did I get around to explaining why that stuff's so cool, though? I don't know if actually I just said what it was.
That's very cool.
It's very cool. You may be able to do, look for some Earth-like planets around very nearby stars with those things. So it may not be quite as far away as I don't really like to think it is, but I think it may be.
This is just a totally geeky comment to add to that because it's very cool. 30-meter class telescope. On a daily basis, you could take images of, for example, Mars or Europa that are basically the equivalent of pretty decent images you'd take in situ from an orbiting platform around Mars or Europa. So 30-meter telescope just transforms what you can do because the bigger the telescope, the finer the images you can make, the finer the resolution of the images. So just even for solar system studies, extraordinary.
Yeah.
And I'm partially saying that because I'm in the process of trying to get a piece of the Giant Magellan Telescope so for Columbia. So we'll see.
Wonderful. We have another one over here.
Great discussion, guys. I love this topic. So, Lee, I wonder if in your book you talk about the origin of life. It seems to me that if we could figure out how exactly life started on Earth and whether it was probable or some crazy fluke, that would give us a better idea of whether life is probable elsewhere. So I wonder if either of you guys has a favorite theory of the origin of life.
Well, actually, I deliberately didn't talk about the origin of life in the book really at all, and that's because I'm gonna take the really easy way out and just say that I think life is kind of a cosmic imperative. I think it just happens in the same way that galaxies and stars and planets happen. I think that life is probably quite common out there, consequently, and I didn't really want to get bogged down in all those details. I didn't want to get to the point where it had to have 2 or 3 chapters all about people mixing things in test tubes and looking at really old rocks. We already have plenty of stuff, lots of the old rock stuff already in there. And the reason why is because you can kind of get lost and you can't see the forest for the trees. The book is really more about what happens on an Earth-like planet when life gets started on an Earth-like planet, and what are we going to do with our moment in the sun. I think in terms of the most likely way that life got started on Earth, so let's see. I'm trying to think of all the different big ways you can break up the argument. I think that I guess I'm kind of, I should really worry about saying names here because I could butcher someone's idea. Jack Shostak, whose group is very active at Harvard right now, the Harvard Origins of Life Initiative. I tend to agree with a lot of what he seems to think about it and what he says, which is that it seems like you need to kind of have something to encapsulate to make cells. You have to be able to get these semi-permeable membranes and things, and then maybe that can allow autocatalytic molecules and things to develop within that concentrated space. Because it seems like either you need something that's going to be, you need your information transmission, you need your RNA, your DNA to replicate and so on and so forth in the primordial soup, but you also need something that can concentrate it and hold it. And so it's like, well, which comes first, chicken or egg? And I guess I think the egg comes first.
Great.
What he said.
I was really interested in what you guys were saying about the political will and the cultural will to fund some of this stuff. And so I was wondering, obviously the moon shot had a president behind it and a political force behind it. And last year, President Obama mentioned the New Brain Initiative in his State of the Union address. And so I'm wondering if you were going to organize this PR pitch to the public for astrobiology, what would your top lines be? What would your pitch be?
Maybe we can just rap back and forth. I'll do like a slogan. You'll do a slogan. We'll just go back and forth. I would keep it pretty simple and say that in this time of declining funds and static budgets and stagnation and all this stuff, you have to make hard choices about what you're going to fund and what you're going to do. And I think that's particularly true for publicly funded science. I think when the public supports your work, you have to have the public engaged with what you do. And a lot of astronomers, frankly, aren't very interested in planets. They don't care. Life is an ancillary question for them. It's not something that they really worry about or think about a lot. It's not in their purview. And naturally, I'm kind of shoehorning a lot of stuff into people's mouths there, but that's my opinion after talking to them. And consequently, some people want to do things like, spend billions of dollars to refine the cosmological constant, the accelerating expansion of the universe. And that's really important. That tells us what the universe is going to do in the far future and kind of our big place in the cosmological scheme of things. It's huge. But I can't imagine any little boy or girl of any race, creed, color, whatever, going out and looking and pointing up at the sky and saying, we know now that the universe is expanding way out there, to 100th of a decimal place. I just don't see that happening. I do see anyone on Earth looking up and looking at a naked eye star and pointing to it and saying, we know that planet has, or we know that star has, a potentially Earth-like planet. We know that maybe there's life there. We can see it's a ball of mud with some oxygen in its atmosphere. That is something that everyone can connect with, and it's just right up there in the sky. Everyone can look up and see it. So I think that sort of profound, simple connection to everyday people is really something that could be exploited a lot in trying to push this forward and saying, this is something we should go do right now.
And if I can add to that, yeah. So I think there's a practical pitch to make as well, and it's a pitch I've made before, which is that part of the reason for finding other worlds and for understanding them and for looking for life elsewhere is in order to understand ourselves better, and not just in some philosophical way, but in a scientific way. We face this enormous challenge right now in terms of climate change, in terms of there being too many humans, in terms of shifting ecosystems, and ultimately part of the reason we have such a hard time in understanding what's happening to the planet is not just because it's a complex system, but because we have nothing to compare it against. We have no comparison. And in science, you always have comparisons, right? You always compare this to that and so on. You're looking at species or you're looking at physics experiments. You can do the experiment different ways. So I think one of the pitches that could be made, it would have to be articulated probably better than I'm doing right now, is that if we truly want to understand the Earth, truly want to figure out a way to not wreck it for us or for anything else living on the planet. And one of the pathways to that is to find other places a bit like the Earth, other worlds where we can examine the fundamental processes behind their systems, behind their ecosystems, even if we were lucky enough to find a planet with life on it. So, the big pitch here is this in part is because it speaks to so many people at a fundamental level, and we think it makes people better if they're thinking this way. They have a degree of cosmic perspective. But just from a hard-nosed scientific point of view, if you really want to figure out how we came to be, how this planet functions now and how it's functioned in the past, how it will function in the future, I think you have to do it this way. I think you've got to find other worlds that are similar enough or even different, because they will challenge you to sort out the science, the physics, the climate modeling, the ecology, the atmospheric chemistry, you name it. That would be my pitch.
Amen, brother.
We're running a little low on time for this evening, so we do have time for one more question.
So following up on the last question, the Apollo had was not just pitched by people who wanted to go to the moon. There was tremendous public support for it. It was almost like the expansionist movement in the end of the 19th century. So do you see any of the current political trends, the public consciousness in the United States, anywhere else, leaning towards making what your answer in particular, Caleb, come closer to reality? You see, like, for example, the climate awareness movement, the conservation movement, getting broad enough support to push something like this?
Okay, I'm going to say two quick things, and one is that actually it's a misconception that Apollo had strong public support throughout its tenure. It actually didn't, in particular after the first moon landing. It dramatically dropped off. That's why, in Apollo 13, the movie, before there was that terrible explosion that threatened everybody's lives, people were instead watching like baseball playoffs. They didn't even carry it on network TV. So people always say like, oh, everyone loved and supported Apollo, but that's actually not true when you look at polls. But granted, that's not really your point. I think that I'll just say that I think, China is sitting on a big pot of money. There's a lot of stuff they could do. Neil deGrasse Tyson loves to say, if China wanted to go to the moon, went to the moon, wanted to put a man on the moon, then by golly, we'd have people, boot prints on Mars, lickety split. So I think in the same way, someone once told me that if China decided to build a big life-finding space telescope, and name all the other Earths out there that they found after great figures from Chinese history, I think that there would be a lot of Americans, red-blooded Americans, who may not otherwise think about this topic a lot, that would all of a sudden be really pissed off and would be like, we gotta spend a lot of money to beat them, whatever it takes. So the problem is that's not really the most productive way to work. A lot of times, of course, it's a lot better if we can collaborate. Right.
Yeah, I think that's a great answer. Is there an undercurrent of support for this? Well, yes or no. I don't think any one country. China, it's hard to know exactly what they're thinking of doing. They're right now they have a rover going around on the moon. Seems to be working tremendously well. They're doing science and so on. So they're clearly working on some pretty big and ambitious science. The rest of the world is so worried about money and so worried about health. Health takes up an enormous amount of research money. There's I shouldn't say this. If there's anyone senior from Columbia here, please don't fire me. Watching what happens at a place like Columbia is actually pretty informative. Most of the donated money that goes into making new buildings, new laboratory facilities, named classrooms and so on, comes from wealthy people who get old, start to get a little sick, or someone they know gets sick, and they start to wonder what they can do with their money to change things. So it goes into health, it goes into neuroscience, or it goes into Alzheimer's and so on. None of which anyone can really argue with. However, that's where people's focus shifts. If you could tell them that there's a new life off-world, maybe
not gonna save grandma.
Right? Maybe you could change it. But it's interesting, and I don't think any one country has really said that it's going to pursue this science. I
would like to just add really quickly that I don't want to necessarily try to point fingers or play the blame game, but I think it's very cogent to note that right now, again, whether it's the Obama administration or NASA or Congress, exactly who's responsible, but NASA's planetary science funding is dramatically being cut right now, and the whole system's being restructured. A lot of young scientists are not able to. They're thinking of going to work in Wall Street or work in Walmart because they don't know where their money's going to be coming from next year and things like that. We're eating our seed corn in that way, and similarly, sorry about that. Caleb.
Sort of biblical.
Yeah. Caleb's argument that this is all part of a bigger picture, that we can understand our own planet and our place and how to better treat it by looking out to the stars and finding other places like it. I think is very, very apt, but unfortunately, I think that's falling on deaf ears when you're talking to most of the people who are pulling the purse strings. You know, they're concerned about climate change, but the way they're looking at it is just, well, let's build more Earth-observing satellites. Let's forget about looking out there, and let's all just turn back inwards and just look at ourselves. And I think that's a real shame.
Great. Well, that was such an excellent chat. On behalf of the Strand, we'd love to extend a huge thanks to Lee and to Caleb for joining us this evening. Thank you all for joining us as well. Make sure you check out their books on the way out. In just a few moments, we'll also have Lee at the table behind me signing some books. Have a great evening.